So let's switch gears a little bit now and start talking about section 2.3, which is about relations and functions. So first we're going to determine if a relation is a function. So a relation, first of all, is just a set of ordered pairs. And as you can see here, your ordered pairs don't have to be ordered pairs of values. So this would include the ordered pair of Bob, comma 18, because Bob is connected to 18. Of John, comma 20, since John is connected to the age of 20, of Bill, comma 21, and of Mark, comma 20. So those would be my ordered pairs. This is called a relation because it's just a set of ordered pairs. The question is this also a function? So a function occurs when every element in the domain being my x's or my first values, every element in the domain corresponds to exactly one element in the range. So here is my range, 18, 20, and 21. And the question is, does each student, in this case, is each student connected to only one age? And the answer is yes, because Bob only has one age, John only has one age, Bill only has one age, and Mark only has one age. So it doesn't matter that John and Mark are the same age, it is still a function. If it were not a function, it would look more like this, where, say, Mark was connected to two different ages, and therefore it would no longer be a function. But the way that it's written now, this is a function. So very, very similar, but this one says, is this a function? And as we just talked about on the last page, I've got an issue right here. Bob is 18 and he's 20. I should have connected that to 21. That would be a nice little fake ID humor. But you get the idea that Bob can't be both 18 and 20. So this is not a function because Bob corresponds to two elements in the range. So again, this is written as an ordered pair, a set of ordered pairs, so we know they're relations. The question is it a function? And really what I'm looking for, and I can, if I want to, do what I did on the other page and write all of my x's, which would be 1 and 0 and -5, and 1, which I'm not going to write again, and 10. So those are all my x's. And all of my y's would be 3, 5, 2, 8, and -5. Again, I just went 1, 0, -5, 1, 10. And then for my y's, I looked at 3, 5, 2, 8, -5. And then I could connect the dots. 1 goes to 3, 0 goes to 5, -5 goes to 2, 1 goes to 8, and that's why I only get to write 1 once. And then 10 goes to -5. And I can see again that this is not a function. But would I have to write it all out like that in order to determine it? No. All I really have to do is look at, do I have, let me erase all my little markings here, do I have an x that occurs more than once? And I do. And do those two go to different values? Yes, they do. 3 and 8 are not the same, and therefore it is not a function. So in my next one, I have 4, 7, 2, 7, 9, 7, -3, 7. So obviously we know what my little mapping would look like if I wrote my mapping out, which is what that's called. They would all be mapped to 7, but is that a problem? No, it's not. This, whoops, I tried to write a y. This would be a yes, it is a function, because 4 and 2 and 9 and 3, -3, we don't have any element of the domain that happens more than once, and therefore it cannot be mapped to something different each time. Again, draw the mapping if you'd like. So let's say now instead of the ordered pairs, we have the actual graph. This is the easiest one. If it's already graphed, we can do the vertical line test. And the vertical line test says, if you can draw a vertical line and it only ever intersects the graph at one point, then it is a function. For instance, the first one is a function because I can draw a line, and I just drew a random line. I could have moved it to the left or to the right, but if you moved it to the left or the right, you would see it's only ever going to touch at one point. If I would have drawn it over here, it's only going to touch at one point. My next one, however, not a function because I've got 2 points. Same thing with my circle, 2 points. So even though I could draw it a vertical line right here and just hit 1, it's possible for me to hit 2, and therefore it's not a function. So now that you know the secret ways of the vertical line test, if I give you a question like this, obviously the easiest thing for you to do is to just graph it on your graphing calculator or on Desmos and just see if it passes the vertical line test. You can also reason through it. For instance, this first equation is a line. I know because it's y equals mx plus b form. And we haven't talked about that yet in this class, so if you don't remember that, don't worry, just graph it. And then, you're good to go. But what I know is this is going to be a line, which means if I were to graph this, it's going to look something like this. And is that going to pass the vertical line test? Yes, it is. The other one, we really haven't talked about how to graph these, but this plus or minus here is what's actually going to make this, so this is going to be a yes. This plus or minus here is what's going to make this be a no. Because if I were to graph, this is saying graph y equals x squared minus 6 and also y equals negative x squared minus 6. So I would graph both of them. And so what it would end up looking like a parabola like this and a parabola like this, because it just flips it over. And again, I would just be graphing this. I would graph both of these on a graphing calculator. And as we can see, I can draw lines and hit more than one point. So that's not a function, whereas it would have been without the plus or minus. So I have given you one of each example to try on your own. So press pause, try all 4, then press play to check your work. For my first guy, remember that I would be looking for, is there an element of the domain that happened more than once? And it in fact did. 2 happened more than once. And 2 is mapped to 4, but it's also mapped to 8. And that is what makes that not a function. For my equation, again, I suggest graphing it. It's the easiest way to go about it. It's going to look something like this. And that, of course, is going to be a function because it passes the vertical line test. It's just the graph of a parabola. Same thing for my graph. I can see if I drew vertical lines anywhere, this is going to pass the vertical line test. It's only ever going to touch one point. And lastly, for my mapping, I'm looking here at my x's. That's all I care about. Does each x only have one line coming out of it? Yes, and therefore that is also a function.